So this is a continuation from part 1, and we ended on question number 4. So now question 5 says differentiate the following with respect to x. Y is equal to x multiplying tan inverse of x. So we're going to apply product rule because we have two functions that are multiplying each other. So we have, this is question 5, question 5.1, y is equal to x, then tan inverse of x. So the u is going to be our x and the v is going to be our tan inverse of x. And when you differentiate x, we get a 1. Differentiate your tan inverse, this is 1 over 1 plus x squared. That's according to the rule. That's what we did. The rule says whenever you have tan inverse of something, the derivative is always going to be u prime over 1 plus u squared. The u happens to be x in this case. So the derivative of x is 1. Then we say over 1 plus the ux. Where there's u, we're putting x. According to product rule, the derivative is equal to u times v prime. That's x times 1 over 1 plus x squared. Then plus, this is a 1 multiplying tan inverse of x. So we can just simplify it to be x over 1 plus x squared, then plus tan inverse of x. So this is what we have. The next question there, or number 5, says sine inverse. This is direct from what we did. Sine inverse the root of x. So y is equal to sine inverse the root of x. So this is the same as using the straight formula for sine inverse. So y is equal to sine inverse. We can write this as x to the power half. That's the u. So the derivative here is going to be, differentiate the u. This becomes half x to the power negative half over x to the power half. This is going to be, we say what? This is the square root of 1 minus x to the power half, the u, then squared. Yeah, so this will end up being half x to the power negative half. Then this is 1 minus x. So that's what we get. So we're just following the rules. Yeah, so this is the rule of sine inverse, is that whenever we want to get its derivative, it's supposed to be 1 over the square root of 1 minus x squared. And here, the x happens to be the root of x. So no wonder we have to differentiate it. That's why we're getting this. Yeah, so if you're having challenges with this, go back to the first video that says further differentiation. It has all the rules that you need for you to be able to differentiate all the questions we're doing here. This again, we're going to use the sine inverse rule. So question 5.3. Yeah, so 5.3 says y is equal to tan inverse of 2 over x. This is the same as tan inverse of 2x negative 1. Just change it in a way that you can use your power rule to differentiate it. So dy dx is equal to, differentiate this, gives you negative 2x to the power negative 2 over, this is 1 plus this guy to the power 2. Yeah, so this happens to be the same as negative 2x to the power negative 2. We have 1 plus, this was 2 over x, remember? It was like this. We can just write it as 1 plus 4 over x squared. We can just leave it here. No need of expanding it or anything. Just leave it right here. All they want to see is this part, where you've applied the rule for the derivative of tan inverse. Then this guy here is going to be a mixture of chain rule with respect to e. So we're having e. So this is question 5.4. Y is equal to e, then tan 2x. So the rule says whenever you have e to the power something, the derivative is u prime, differentiate that thing, then e to the power u. That's the rule. So when we say dy dx, this is going to be differentiate tan, differentiate this. So look at what we are getting, 2x. So the derivative of 2x is just 2. The derivative of tan, you know it's sec squared. We put our 2x back because that's like your theta. So it will be 2 sec squared 2x. then you have e to the power tan 2x. That's what you get. So this is basically the solution to your question number 4 on 5. Then the last one on number 5, question 5.5. Question 5.5, y is equal to e x squared then over x. So what rule are we going to use here? Because they are dividing each other, the rule we are supposed to apply is quotient rule. So the u is going to be e x squared. Your v is just going to be equal to x. Differentiate the u, so u prime is going to be 2x, e to the power x squared. Then v prime is just going to be 1. Quotient rule says v times u prime minus u times v prime over v squared. That's a rule. So v is just 1 x. So we're saying x times this. That's going to give us a 2x squared because of the x and the x. Then we have this minus v prime times this guy. This is x squared. Down we just have x squared. We can just leave it there. In as much as we're able to see there's something that we can factorize on the numerator part. But this is basically how we were going to do it. So this answers your question number 5. Yeah, just remember the rule. Whenever it's e to the power something, you differentiate that power, write it down, then write back what you initially had. So e to the power, the original thing that you had. Then question number 6. This was a little bit interesting because it was a repeating sequence of derivatives. They are saying given that y is equal to sine x and the derivative of y happens to be sine x plus a, sine of x plus a, and the second derivative is going to be sine of x plus c, find the values of a, b, and c and a formula for the nth derivative of our x. So here we're going to write all the three derivatives given. So I need you to pay attention here. So you have y. So this is question number 6. So y is equal to sine x. That's what we're having. Then they are saying the first derivative is supposed to be equal to sine x plus a. And the second derivative, when you differentiate it for the second time, you're supposed to get sine of x plus c. That's what you have. Okay, so the first step that we're going to do here is to differentiate the y. So when we differentiate y, we're getting cos. That's the first thing that we do. So, and they're saying the derivative is supposed to be equal to sine of x plus a, meaning cos x can be equated to this because these two are the same, right? You're seeing that. So this implies that cos of x is the same as sine of x plus a. That's the first thing that you do. And there's an identity that relates cos and sine in this manner. And that identity will simply have a is equal to 90. So this is going to be, so we say hence a is equal to a 90, something like this. Because there's a rule. It's a standard rule that says sine is always 90 degrees ahead of cos. That's how we solve this. That's how we basically prove this for anything. So it's like we say, imagine we say let x be equal to something acute, right? Let me just show you how we can prove that it's actually 90. So if we replace where this, we put this guy, then here I'm going to say this is the same as sine. This is, let's say, 30 plus a. So look at what we're going to get. So cos 30, we already know this. So cos 30, according to your special angles, if we have a 60 there, we have a root 3 there, we have a 1, we have a 2. So cos 30 is adjacent over hypotenuse, which is just root 3 over 2. This side, you can just say, we can just write it the way it is. This is going to be a, look at what you're going to get here. This is, I'm just trying to show you how the 90 came about. So we're going to take the sign this side. So it's going to be sine inverse of root 3 over 2 is equal to a 30 plus a. So if you have sine inverse of this guy here, sine inverse of what? Sine inverse of root 3 over 2, this is going to be what? Is it 60? It could be a 60. Another thing could be, apart from 60, we can say it's what? Because sine is positive in the first and in the second quadrant. So we have a 60, and we also have what? 180 minus 60, that's 120. So we have 120 as well. Equate both of these possible angles to 30 plus a. So when you take the 30 this side, that's going to be 60 minus 30, right? That gives you what? A is equal to 30. Then the other one is going to be equal to, when you take the 30 this side, 120 minus 30, that's going to give us 90. So we take the biggest one. So the biggest one is one that we are considering. So that's how the answer is taken to be 90. So A is simply 90. So hope that explains why I'm saying A is 90 here. So that's a basic logical explanation as to why A is this. Then they also said the second derivative is equal to sine of x plus c, right? So we differentiate it again. We've said dy dx is actually the same as what? Is actually the same as cos. That's what we've said, right? We differentiate this guy again to get the second derivative. The second derivative has to be negative sign. Now they are saying, they've given us that the second derivative is already sine inverse of x plus c. That's what they said. So we're going to equate negative sine a, negative sine x, to be equal to sine x plus c. So the angle given here is going to give us a negative outcome by the time we're done solving everything. So meaning the first place where sine can be negative is in the third quadrant. So meaning C has to be 180 to push something that was acute and push it in the third quadrant. So here C is going to be equal to pi. So this gives you your answer to this question. Because there is a question, if you remember, for you guys doing math 1100, this is your tutorial sheet. Remember the tutorial sheet on trigonometry, there's question number 4, 5, and 6. How they were giving you expressions like this, sine theta, to say simplify something that looks like this, sine of, let's say, we say what? They say theta plus, let's say, pi. Remember? Then you say this is the same as negative sine theta, right? It's the same concept. That's where this is coming from. Yeah, so here C is going to give us pi. Now, for us to be able to get B, they are saying we have, from the question, we have sine A. We have A, we've gotten A, we have C there. So they want us to get the general formula, which is also going to help us to get the expression that can allow us to get anything that has a B inside. So this is going to be written as follows. So y is the same as sine x, that's what they said, meaning y can be the same as sine of x plus b. So this can be y. The only way it can maintain being positive is if b is equal to 0. That's the only time that this can continuously be found in the first quadrant, or rather be maintained as positive. So we shouldn't move it anywhere, because anything we get is supposed to be between 0 and 180. So the minimum number that we can have is 0. So b is going to be said to be 0. That's the first assumption we do. And this will make sense because for us to get the general formula, I want you to look at a certain pattern. So this, to answer our part, so part 1, we've said our A is 90. Then our C, we said it's 90. Our B, we've said the answer is 0. For part 2 of question 6, we have to differentiate this over and over again. So I want you to notice that y is equal to sine x. The first derivative is equal to cos x. Look at the second derivative. The second derivative is going to give us negative sine. The third derivative is going to give us negative cos. then the fourth derivative is going to give us sine again. So in all these cases that we are having, we can change this because we know what cos is. We said cos is the same as sine, so we're going to be making replacements. The first expression we did was cos x was the same as what? Sine x, x plus what? Plus the first derivative, which is a. We made it to be a. So where there is cos, I can replace here. Where there is cos, I can replace with sine because I want to have sine throughout. Yeah, so I'm going to replace this part here where there's cos. I'm going to put, because cos x is the same as this, I'm going to say sine x plus a. Then where there is negative sign, remember, this is the same as, it's in the what? It's in the third quadrant. It's the same as x plus what? Plus pi. That's what you have. Here, a, we're from finding a. A, we found it to be 90, by the way, so I can put back my 90 there. We have that. Then, this guy again, we can replace. That's the same as, this here is the same as sine, where there was cos, x plus pi over this. Yeah, so it can continuously go like this. We can just go down, and this is going to be the same as what? This is now in the, this is going to be happening in the what? In the fourth quadrant, is it? Yeah, so we're going to add a what? A 3 here. That's 3 pi over 2. Then the last one has to be x plus 2 pi. This is the same as sine x plus 2 pi. Because it has to be found in each and every quadrant. Yeah, so the general formula, to answer your question number 6, the general formula, this is equal to sine, then we say x plus n multiplying pi over 2. So this here gives us the general formula. In other words, we just have sine x plus, this is n with a pi with a 2, so something like this. That gives you a general expression. So this answers your number 6. So hope this is okay. Then question number 7, they want us to find the derivative of y with respect to x. This is implicit differentiation, so this is very, very straightforward. We said whenever we are carrying out implicit differentiation, we are always going to be differentiating every letter, but whenever we differentiate a letter that's not x, we put dy dx alongside the letter that the derivative, the answer that you've gotten. Yeah, so for the number 1 there, so we have x squared, this is 7, x squared plus y squared is equal to 16. So when you differentiate this, this is 2x, differentiate this, this is 2y, put a dy dx, then this gives you a 0. This is the same as 2y, dy dx is equal to negative 2x, divide here, meaning you say dy dx is equal to negative x over y. So that's what you get as the derivative for number 7a. Hope that's okay. We're just trying to make dy dx to be the subject of the formula. That's the whole idea here. Yeah, you really don't have to. You could have just left it here. It's still okay even if you were to leave it there. Yeah. The next one is saying this part there. So we have x squared, 7, 2. So we have x squared plus x and y squared is equal to 6. So this is going to give us 2x. Then because they are multiplying each other here, we're supposed to use product rule. So your u is going to be equal to x. The v is going to be y squared. So u prime is going to be 1. V prime is going to be 2y dy dx. Then we cross multiply this. So we're going to have 2xy dy dx, then plus y squared is equal to 0. Then we have 2xy dy dx is equal to negative y squared minus 2x. Then you have 2xy, then you have 2xy. This is dy dx is equal to negative y squared minus 2x over 2xy. So this is what you get as the derivative of question number 7.2. The next one is just the same thing. We're just following the rules. So question 7.3, we have x plus sine y is equal to x and y. This is going to give us 1. This is going to give us cos y. Then put a dy dx. Here they're multiplying each other, so we're going to use product rule as well. So v is equal to y. So u prime is just going to be 1, v prime is just going to be 1. So we attach a dy dx to the 1 because the letter we have differentiated is y. Then x times this, that's going to be x dy dx, then plus y, this times that. Then from here, we make dy dx to be the subject. So we are going to have cos y dy dx minus x dy dx is equal to y minus 1. Factorize dy dx there. So we have cos y minus 1 is equal to y minus 1. This is cos y minus 1. And cos y minus 1. Cancel this. So dy dx is equal to y minus 1. Cos y minus 1. So we have this. This is what we get. And the next one is straightforward, so I'll just do it right here. This is going to be 1. The derivative of x is 1. The derivative of tan, we said it's sec, right? Sec squared. Then put a dy dx. Meaning you can just divide both sides by sec squared. So cancel this, meaning your dy dx is equal to 1 over your sec squared. Yeah, so this gives you your final answer. That answers question number 7.4. Then the last one, try to attempt it. Try to pause the video and try it before we do it together. So this is going to be needing us to apply product rule because we have this. This is EY plus that. This is equal to 0. So use product rule there. It's going to be x dy dx plus a y, then plus the derivative of y is supposed to be dy dx because it's 1, right? Then e to the power y is equal to 0 already. Then you are going to have x dy dx plus dy dx with an ey is equal to negative y. So this is going to be dy dx here, x plus ey, then this is equal to negative y, x plus ey, x plus ey e to the power y. So meaning the dy dx here, dy dx is just going to be negative y, then we have x plus ey. So this is what we get as a derivative. That answers the whole lot of question number 7. And like I said, it's not really necessary for you to make dy dx the subject. As long as you've differentiated, everything is okay. Yeah, so you see on the next questions as to why I'm saying that, because we'll have to be getting the slope, or rather the tangent and the normal, so all those things are just going to be straightforward without needing us to make dy dx the subject. So question number 8 is an application question. They are saying the curve, this is the equation, passes through the point -1 and -8, and at that point, the second derivative and the first derivative are both going to be equal to 6. Find the values of a, b, and c, and then sketch the curve. So that's what they want us to do, to sketch the curve by the time we're done. So we're going to have dy dx here. So I'll just write the equation here. So question number 8, they're saying the curve equation is y is equal to x to the power 4, then plus a x squared, then plus, this is bx, then plus a c. This point, this curve passes through the point -1 and -6 or -8. then both the second derivative and the first derivative at this particular point that is given, they are both equal to 6. So we differentiate this for the first time. Get your dy dx. This will be 4x to the power 3 plus a 2 ax, then plus a b. Then in this particular first derivative that we're from getting, wherever there's x, we should just replace with -1. We should equate it to 6. So we have 6 is equal to, so wherever there is x in the first derivative, we replace with -1 and equate everything to 6, because we're saying the first derivative is equal to 6 when we replace it with what? When we replace x with -1. That's what we're saying, because they're all going to pass here. The original curve, the differentiated curve, the first derivative or the second derivative, they're all the three, they're going to pass in at this particular point. So here it's going to be 6 is equal to -4 minus 2a then plus b. This is going to give us a 10 is equal to -2a then plus b. So we keep this guy, and then we differentiate this again for the second time. So to get the second derivative, this is going to give us a 12x to the power 2 then plus 2a. And we're saying when you put -1 where there's x, the whole thing has to become 6 again. That's what they say. The second derivative is also 6 at the same point. So this is going to be 12 plus 2a is equal to 6. That's a 2a is equal to 6 minus 12. So 2a is equal to -6. And you divide by that, so a is equal to -3. When you get a -3 there, we replace it here because you know what a is, right? A is -3. So you can replace it there. So you have 10 is equal to -2, -3, then plus b. This is going to give us a 6. The 6 goes on the other side. So 10 minus 6, that's going to give us a 4. So b is actually equal to a 4. So we have the b, we have the a. We can replace them in the original question now. So we're going to go back in the original question and say, therefore, our y is equal to x to the power 4. Then this is supposed to be 4a. So this is this to the power 3. It's 8. Then b is simply a 4. X. Yeah, then plus a c. This curve is still passing at the point -1, -8. But we don't know what c is. So we're going to replace, wherever there's x, we put -1. Wherever there's y, we put -8. So we put -8 there is equal to -1 to the power 4. 3, -1 to the power 3. Plus a 4, -1, then plus a c. That's -8. This is a 1. This is going to give us a plus 3 minus 4, then plus a c. So we're looking for our c. This is -8. That's a 4. That goes away. So c is equal to -8. So if this is correct, meaning the c is going to allow us to have a complete polynomial now. So the polynomial now that we're supposed to sketch is x to the power 4. Then we have what? Minus 3x to the power this, then plus 4x, then minus 8. So this is the polynomial that we're interested in. And they said we need to find the values of a, b, and c, and then sketch the curve. We're just in need of a sketch. So we're going to say something like this. It has to touch the x-axis at 4 particular points because the highest degree has x. And we're supposed to touch the y-axis at -8. So we need to touch the y-axis at -8 somewhere here. So we need that. Then we have to get the roots of this expression. So if we try to do that trial and error method, or rather the other simpler method we would have done is just to get the turning points or the stationary points, since this is under calculus. But I'll go through the longer route, which is using factorization of polynomials. That's what we're going to do. Okay, so I'm just trying to cross-check. So this is going to give us -8. Okay, so hope everyone is getting the same outcome so that we're able to just get the correct thing. So our b is a 4. So we're going to replace where there was a b. So b there is 4. Then this is -3, right? So now I want to see whether we're getting the right thing at the end. Okay, the b is there. So with a negative, that becomes negative when we're solving this. Okay, it gives us this. Okay, so now if we're trying to solve this expression to factorize it completely, we focus at the constant here that we got, which is -8. So what numbers can divide 8? So we're just trying to make this to find proper factors. So x is equal to 1. If I put 1 there, that's going to give us 1 minus 3 plus 4, then minus 8. This does not give us a 0. If I try -1, so this is not working. X is equal to -1. This is giving us what? No, it's not going to work. That's a 1 plus 3, then -4, then minus this guy. So this again is not going to work. X is equal to 2. So if we put 2, if we put 2 there, that's going to give us a 16. Okay, so we're having this. This again does not give us this 8, right? This is what this is going to be. 2, that's 8, that's 24. So this is what we're getting, 16. So this is not working. So the easier route we can take here is just to differentiate this and use calculus, because they just want a sketch, right? Yeah, they did not specify the method to use. So we're going to differentiate this for the first time. And when we do so, the derivative is just going to be 4x to the power 3 minus 9 x squared, then plus a 4. Then equate this to 0. So we're trying to equate this to 0. We try to solve. So if we're trying to solve, is that a 2? Oh, this is not a 2. Okay, sorry guys, my bad. This is supposed to be, this is not a 3. I'm using a 3 here. It's supposed to be a 2. This here is supposed to be a 2 there. Yeah. So this now changes everything. I made a mistake there. Okay, it's supposed to be a 2. Let's see if I did the same mistake everywhere. So if I take it back, okay, so I repeated the same mistake everywhere. Okay, so let me just redo it here. I'll cut this part. Okay, so question 8, let's just restart it again. Question 8, they've given us a curve which is y is equal to x to the power 4, then plus a x squared, then plus bx, then plus a c, and it's passing at a point. This is the point that we're passing at. Okay, so now if we differentiate it for the first time, this gives us 4x3, then now we're going to have 2ax, then plus b. Then again, if we differentiate it for the second time, this is going to be 12x squared, then plus 2a. So if we put -1 there, that's going to give us 12. -1 squared plus 2a is equal to 6. They said it's a 6, right? They're both giving us 6. That's what they said. At that particular point. At that point, this is that. So here now we're going to have what? To have 12 plus 2a is equal to 6. Then you have 2a is equal to 6 minus 12, meaning 2a is equal to -6 divided by 2. So a is equal to -3. That's what we are having. So I hope this is okay. We're using the second derivative to get a. So we replaced x here in the second derivative. We've used this guy. Then we're supposed to use the second derivative as well, because they said even the second derivative gives us 6 at that same particular point if x is equal to -1. So if we do this, 2, where there's a, I put 3 now, -3. Where there's x, I put my -1. This should give us what? A 6. That's what they're saying. So this is going to give us negative 4, then minus positive, that's going to be positive 6, then plus b is equal to 6. So meaning b is just equal to 4. Because these guys are going to cancel, right? That's what you get. Then if we know the a and the b, according to the question, y is equal to x to the power 4. Then a is negative 3x squared, then plus our b is 4x, and plus a c. We can replace wherever there is x, we put negative 1, and wherever there is y, we put negative 8. This is going to be 1. That's going to give us negative 3. That will be negative 4 plus c. This will be negative 8 minus 1 plus a 7. This is c. So according to this, we have negative 9, then plus 7, c. So meaning c is equal to negative 2. Yeah, so the question is just the same thing. We'll have y is equal to x to the power 4 minus 3 x squared plus 4x, then minus 2. So this right here is the full polynomial that they actually had. So if we want to get the sketch, if we want to sketch it, we can just look at the last digit. Let's try to simplify it. So if I try 1 in this expression, that's going to be 1 minus 3, then plus 4 minus 2. This here gives me negative 2, this gives me a 2, so this is actually 0. So x is equal to 1 over x, meaning x minus 1 is a factor. I'm going to proceed using synthetic division to simplify what we are having. I'll put 1 this side. Then I'm going to say, I put the constants, the coefficients. I mean, there's 1, there's 0, negative 3, there's a 4, there's a negative 2. I can bring this 1 down, so this is going to give us 1 multiply, that's a 1, negative 2, that's negative 2, that's a 2, that's a 2, that's 0. Then from here we are having that the polynomial is the same as x minus 1 and x3, x squared minus 2x, then plus 2. Then from here again we differentiate this, that's going to be 1, 1. I can say negative 1 can work actually. Here is it. We have 1, that's going to be negative 1. That's going to give us a plus 1. This is going to be okay, plus 2, then it won't work. So what other thing can work here? If we use what? If I use 1, that's going to be 1 plus 1 minus 2 plus 2. Okay, this doesn't work. So we have to simplify this guy. Is it simplifiable? So we're just going to have is this possible? So since we're only able to get one factor according to this, I'm not sure if there are other factors that you can easily get. I'll resort to calculus. We differentiate it for the first time. So y prime is going to be 4x3, then minus 6x, then plus 4. Equate this thing to 0 and try to get the stationary points. I can divide throughout by 2. That's going to give me 2x3 minus 3x, then plus a 2 is equal to 0. So according to this, is there any factor that we can think of? Is there any possible number that we can use to make this thing to be a 0? This is going to give us what? This is going to give us, if x is equal to 1, that gives us a negative what? A negative, so 2, 2, 2. That gives us a 1. So this again is failing. So the only thing that I'm going to do is just to show that the whole sketch just passes at the point for the first guy that we found, which is passing at 1. So I'll just show that it passes at 1, touches the x-axis at 1, and also touches the whole question has what? Negative 2, right? So it touches the thing at negative 2 on the y-axis. So it's supposed to be something that has a repeating root, if I may assume. Okay, so according to my findings, when I use a calculator, they are very, very small numbers, because the only thing you get here is one answer, like the way we got previously. It was just one. So we have to make sure that it passes at 4 particular points. So you have something that looks like this. Arbitrarily, you have these as your stationary points, your minimum there, your maximum, and your minimum at this particular point. The sketch will just look like this. Yeah, so I'll talk about this question more in class. So I'll discuss this further. I'll show you how to use the second derivative test and everything else. Yeah, so let's proceed to this guy. The next question here is number 9. So number 9 says, find the equation of the tangent line and the normal to the graph of the equation at the point indicated by this. So the first thing here is that you differentiate. That's 2x plus 2. Plug in the negative 3 there. That's going to be 2 negative 3 then plus 2. This will be negative 6 plus 2. The answer we're getting is a negative 4. So after you get your negative 4, we're supposed to write the equation, but the equation needs a point, right? Negative 3. We need a corresponding y value. So we need to place x negative 3 wherever there's x to get the y value. This is going to be negative 3 to the power 2, 2 negative 3 plus 1. This is a 9 minus 6 then plus 1. That's going to give us a 4. So this is a 4. The equation of the tangent is just going to be y minus y1. The slope that we're from getting, this is the slope, x minus x1. So we replace y minus y1, that's 4. The slope is negative 4. X minus the value of x, which is negative 3. This will just be negative 4x. This is positive, that will be negative 12. Y is equal to negative 4x. We take the 4 this side, that's going to be negative 8. It reduces. So this is going to be the equation of the tangent. And if you want to get the equation of the normal, there's a rule that says the gradient of the tangent and the gradient of the normal, whenever you multiply them, they should always give us negative 1. So if we put negative 4 there, we're looking for m2. m2 is just going to be equal to 1 over 4. Once you get the 1 over 4, at the same point again, the equation of the normal is y minus 4 is equal to 1 over 4, x again minus this. This is y minus 4 is equal to 1 over 4. This is x, then plus 3. Y minus 4 is equal to 1 over 4x plus 3 over 4. This is just 1 over 4x plus 3 over 4. Take the 4 back this side, that's going to be that. And you have y is equal to 1 over 4x. Add up this, you get the common denominator is 4. That's going to be 3 plus 16. So y is equal to 1 over 4x. And plus that is 19 over 4. So this is going to be the equation of the normal line. So that's what we do on question number 8. The process and the procedure is the same, so to say, for all the questions here. So try to pause the video and check out the answers we're going to get for the remaining 2. We'll see if you get the same. So question number 9.2, we have to get the derivative. So we get the derivative, that's going to be 3x squared, then plus 2x. Then in this particular guy, we are going to replace the x being this. So we're going to put 3, say negative 2 over 3 squared plus a 2, negative 2 over 3. This is going to be 3, 4 over 9. This is minus a 4 over 3. And this is going to be 3 there is 1, 3 there is 2. 3 there is 3, I mean. That's going to be your 4 over 3 minus your 4 over 3. This gives us a 0. So if we get the derivative to be 0, we can now replace the x value in the original to get the y value. So replace this value there. We're going to have y is equal to negative 2 over 3 to the power 3, then plus a negative 2 this squared. This is going to be negative 8 over 27 then plus a 4 over 9. When we add these, this is going to be a 27 negative 8. This is going to give us a 3. 3 times that, that's a 12. So 12 minus this, that's a 4 over 27, meaning the whole equation is just y minus 4 over 27. That's a y value. The slope is 0, so everything becomes 0, even if you have this. So y is just equal to 4 over 27. Yeah, the same will be the equation of the normal as well. They will be the same, because even if you say 0 m2 is equal to negative 1, the outcome is still going to be that. Yeah, so this is what we have. Then the last question on number 9 is the same, so I'm going to leave this to you as a task. I won't do this, so you can just send it to me on WhatsApp to see if you are getting the slope and the correct normal and tangent equation. Yeah, so to see if you're understanding the concept, just confirm on WhatsApp. The next question is number 10. Number 10, they're saying, find the equations of the lines tangent to the curve this at any point where the curve intersects the x-axis. So we're simply going to solve the equation and find all the possible places where the curve is touching the x-axis. So we have, this is y. This is question number 10. Yeah, so this is y. So y is equal to x to the power 3. Then we have negative 3x squared, then plus a 2x. So this is going to be y, x, then x squared minus 3x, then plus 2. X is equal to 0. We have this, we solve it separately. This is going to be that. Then we have x squared minus 2x minus x plus 2 is equal to 0. This is going to give us x and x minus 2 minus 1. And x minus 2 is equal to that. Then minus that is equal to 0. X is equal to 1 and x is equal to 2. So we have 3 places where we are touching the x-axis. So there is 0, yeah, then there is 1, so there's 0, 0. We have this. So these are the 3 possible points that we need to check, or rather write equations at these 3 particular points. So from the statement, they are saying we need to find the equations of the lines that are the lines tangent to the curve at any point where the curve intersects this. So we just have to differentiate this and get the slopes, because the slopes won't be the same everywhere. So this is the equation was already here. So I'll just differentiate it. Let me put it in a different color. So just get the derivative of the question. The derivative here, when you differentiate it, this is equal to 3x squared, then minus 6x, then plus 2. That's the derivative. So 3x squared, so the derivative is 3x squared minus 6x, then plus 2. So plug in, I'll just show you for A, then you can do for the rest. So plug in 0 in this equation. So I want to find the equation of the tangent at this point. Plug in 0 here, you get your m1, the slope to be 0, 0. That's going to give us a 2, meaning you need to write the equation at 2x minus 0. So this is the tangent that is passing at the first point. This will be y is equal to 2x. The same applies here. Plug in 1 in the derivative here to get the tangent. So this is at A. At B again, you can do the same. To get the tangent, just plug in the 1. Plug in 1, that's going to be m1 is equal to, there's 3, there's a 1, minus 6 and 1, then plus a 2. This is 3 minus 6 plus 2. This is going to be negative 1. Once you get to negative 1, then make the equation. There is a 0. This is negative 1. X minus 1. Yeah, so this is going to be negative x then plus 1. So this is the equation of the tangent at point B. Yeah, so you can do the same for C. The outcomes will be correct. Yeah, so this is okay. Hope you've gotten what we need to do here. Then look at number 11. These are just application questions. Find the equation of the tangent to the curve that is perpendicular to the line, this guy here. So the first thing that we just have to do is to make y the subject. That's what we need to do. Yeah, so we can first of all get this to be negative 2y is equal to 1 minus x. Okay, let me just write it back. So we need a line that is perpendicular to what we have. That's question number question number 11. Just a minute. Yeah, so question 11, we're given y is equal to, there is x squared, then minus 2x. The line that we are, this is the curve, by the way. Yeah, so they're saying that is perpendicular to this line. Find the equation of the tangent that is perpendicular to x minus 2y, then is equal to 1. Negative 2y is equal to 1 minus x. Divide by negative 2, divide by negative 2, y is equal to 1 over negative 2 minus x over negative 2. So y is equal to negative 1 over 2 plus x over 2. And this is just going to be the same as y is equal to x over 2 minus half. So think about it like it's a straight line equation that looks like this. So we are going to say y is equal to half and x then minus that. So now the gradient, the slope, this is like m2. m2 is equal to half. This is like the gradient of the perpendicular line, which is the normal line, because it's perpendicular, or rather 90 degrees with the tangent. So using this, I can get the gradient of the what? I can get the gradient of the tangent. This is going to be half m1 is equal to negative 1, meaning m1 is actually negative 2. So now that we know the expression, this guy here, this is m1 is equal to negative 2. We can now equate the two equations. So now that we have the gradient of the tangent, which is this guy, we can just differentiate the original guy. Instead of equating them, rather, we can just differentiate the original expression, which is 2x minus 2. It's like we're trying to get the stationary point. So this is just going to give us x is equal to 1. The corresponding value is that when x is equal to 1, in the original equation, put x to be 1, you get 1 minus 2. That's a negative 1, and the slope is negative 2. So we can now create the equation of the tangent. This is going to be negative 2x minus 1 plus 1 is equal to negative 2x plus 2. This is y is equal to negative 2x plus 2 minus 1. Y is equal to negative 2x then plus 1. This right here is the answer to the question, because this is the equation of the tangent. That's what they wanted. Just this part here. Yeah, because when you put, we're getting what? When you put, oh, they're saying the slope, right? We're saying the slope. Sorry, this is, this guy here, guys. The slope of the tangent is negative 2, right? That's the slope of the tangent. So I want to get the point where the tangent was passing, right? Not just any stationary points. It will just like too open. So after we get the first derivative, which is this guy, we equate it to this number because there's a point that we're interested in. When that value of x is replaced there, that's how we got the -2. So now we're just trying to say what value of x can make the derivative to be equal to what? -2, meaning that's the point where the tangent was passing. So this is going to be 2x is equal to what? 0, meaning x is equal to 0. When x is equal to 0, y will be 0 in the original curve equation. So to get the equation of the tangent, we'll just get this x minus 0. Yeah, this will give you y is equal to -2x. That's what you just get. Yeah, this is the correct one. I hope you understand what I've done. We got the first thing, which is getting the derivative. And using the derivative, we can now equate it to the differentiated expression of the curve. So the derivative is 2x. We're equating it to the gradient, which is the gradient of the tangent that we got, so that we know the point we're dealing with. Yeah, and then that point will help us to create the equation of the tangent. So that's what we did. That answers your number 11. So now the next part is question number 12. So question 12 says, consider the function g of x, which is given as follows. Find the equation of both the tangent and the normal to the graph g at the point 1, 0. So they already gave us the point. We just have to differentiate it. After we differentiate it, we now replace 1 to get the m1. Using the m1, we can get the m2. Then from there, we can get the two equations for the tangent and the normal. That's what they want. So now we'll just use your rule here. This is going to be what? Quotient rule, right? We're differentiating this using quotient rule. Or simply put, we're going to use power rule. We can actually use power rule for this. Yeah, so let me just show you how we can use power rule. So you have to see if there's a possibility of you being able to simplify the equation that they've given you. Yeah, so this is question 12. Your g of x is given as 1 x to the power 3 is x to the power 4. This is the same as 1 over x to the power 4 minus x3 over x to the power 4. This here is the same as x to the power -4. This here is the same as 1 over x. So I can write this as x -1. Hope that's okay. That's your g of x. When you differentiate this, we get -4 x, then this is -5. This is positive x, then -2. This can be written back as x5, 1 over x squared. That's the derivative. That's what I've gotten. So even if you use quotient rule, you need to get something that will be like this, and you replace where there's x, put your 1. The outcomes are still going to be the same. -4 plus 1, meaning we're having m1 is equal to a -3. So already you know to say the equation we need for the tangent at the point 1, 0 is just y minus 0, -3, x minus 1. This is just -3x and plus a 3. So that's what we have. Then for the normal, we'll just say m1 and m2 is equal to -1. So this gives us m2 to be equal to 1 over 3. So we have y minus 0 is equal to 1 over 3, x minus 1. This is just y, 1 over 3x, then minus 1 over 3. So this right here is the equation of the normal that they wanted. Yeah, so it's the same thing really. Even if you use quotient rule, the answers will still be the same. Yeah, so question number 13 is the same thing. We just have to differentiate this using implicit. So I'll solve this separately here. So we have question 13. They've given us x to the power 2 plus 3x and a y squared, then minus y to the power 3 is equal to, this is a 9. So this is going to be 2x plus, here we have your u is 3x, and your v is y squared. So u prime is equal to 3, then v prime is equal to 2y dy dx, because it's implicit, right? Whenever there's y and you differentiate it, we have to put a dy dx alongside the answer that you've gotten. Yeah, so I'm going to cross multiply now. So 3 times y squared, that's going to be 3y squared, plus this times that, that's going to be 6xy dy dx, minus 3y squared dy dx is equal to 0. So this is a typical example that I was saying you really don't have to make dy dx the subject, because if we're looking for the tangent equation at the point 2, 1, we just have to replace wherever there's x, put a 2, wherever there's 1, put your, wherever there's y, put a 1, because we have both letters in this question, x and y. So now we do the replacement. There is 2, where there's x, I'm going to put a 2, plus 3, where there's y, I put a 1, plus 6, I put a 2, I put a 1, this is dy dx. And minus 3, I put a 1, this is dy dx as well, is equal to 0. This is going to be a 4, this is plus a 3, this is plus a 6. I'll call this m1, minus 3m1 is equal to 0. Dy dx is just like the gradient, the slope of the tangent, right? So I'll call them that. This is a 7. So 6 minus that, that's going to give us a 3m1 is equal to negative 7. So I can divide by 3, meaning m1 is equal to negative this. So now that we know the slope at this point, which is this guy, we can now get the equation, because y was 0, y was 1, I mean. Y was 1, negative 7 over 3, and x was 2. So this is the equation of the tangent, 7 over 3x, positive 14 over 3, this is y is equal to negative 7 over 3x, plus 14 over 3, plus 1. This is y is equal to negative 7 over 3x. Add this, that will be a 17 over 3. So we get this. So this is what we get. This is going to be the equation of the tangent that they were looking for. So this answers your question number 13. What we did on number 13 is the same thing that we do on number 14. So I'll leave number 14 to you as a task, except here we're going a step further to get the equation of the norm after you do implicit. So I'll differentiate this for you. Here we're going to use chain rule. That's going to be 3 outside. Differentiate what's inside. That's a 1. This is going to be dy dx. When you differentiate this, rewrite back what you have, x and y, reduce the power, it becomes a what? A 2, right? This side you're just going to get a 2x, then plus y, which is just dy dx. So this is the derivative. Where there's x, put 1. Where there's y, put your 0. So let me just do this for you easily, quickly here. Maybe you can just try to follow through. Yes, this is already m. Could just call it m1 really. Put 1 plus 0, right? This is just 1 squared. This is just a 2, and m2. m1, I mean m1. So this is going to be a 1 there. So we're having 3 plus 3m1 is equal to 2 plus m1. So this is going to be 3m1 minus m1 is equal to 2 minus 3. That's going to be 2m2 is equal to negative 1. Yeah, so meaning m1 is equal to negative 1 over 2. This is the equation of the tangent. So using this, we can get the equation of the normal. So the equation of the normal is just going to be the following, negative half and m2. Yeah, so meaning m2 is just going to be equal to a 2. At the same equation, at the same point, I mean. So replace where there's what? The equation number 14 is 1, 0. So we have this is 2 and x minus 1. Y is equal to 2x minus 2. So this right here is the equation of the normal line. That's what they wanted. So this is the answer to your number 14. Try to do it and check. So this I've already done it for you. We're using chain rule. If you wanted, you'd have expanded this then, so, but then it will just become very long. Yeah, so just use chain rule. Bring the power down, differentiate what's inside, then rewrite what was there, reduce the power by 1. And remember, whenever you differentiate y, we have to put dy dx alongside the answer that you've gotten. Yeah, then number 5. Number 5 is an implicit case again. They're saying, consider the equation, this guy here. Find the 2 points where the curve intersects the x-axis. Show that the tangents to the curve at these points are parallel. So if things are parallel, meaning they'll have what? They'll have, what's their gradient? They'll have the same gradient, right? The slope is going to be the same. Okay, so for the purposes of this this whole session, I'm just going to cut it here. Then I'll continue number 15 in the next part, so that I just upload it at 1 hour duration. So thank you so much for watching. I'll see you in the next video.